Settle into a comfortable position, let the room grow quiet, and allow your breathing to become slow and easy. Tonight, we are traveling through more than 160 million years of dinosaur history. We will move gently from the first small dinosaurs of the Triassic, through the immense forests of the Jurassic, and into the flowering landscapes of the Cretaceous. Each fact is based on evidence from fossils, rocks, trackways, living birds, and the careful work of paleontologists. There is nothing you need to remember. Simply listen as one discovery leads softly to the next. Dinosaurs first appeared during the late Triassic period, roughly 230 million years ago. The oldest widely accepted dinosaur fossils come from South America, although early dinosaur relatives lived across the connected continents of Pangaea. The word dinosaur means terrible lizard, but dinosaurs were not lizards. British anatomist Richard Owen created the name Dinosauria in 1842 after recognizing that several large fossil reptiles shared a distinctive set of anatomical features. Dinosaurs are defined by details of their skeletons, especially the arrangement of the hip and limbs. Their legs stood beneath the body, giving them a more upright posture than the sprawling stance typical of many other reptiles. Not every prehistoric reptile was a dinosaur. Pterosaurs were flying reptiles, while ichthyosaurs and plesiosaurs lived in the sea. They shared the Mesozoic world with dinosaurs, but belonged to different branches of the reptile family tree. The Mesozoic era is divided into three periods: Triassic, Jurassic, and Cretaceous. Dinosaurs lived through all three, adapting to enormous changes in climate, vegetation, coastlines, and the slow breakup of the supercontinent Pangaea. Early dinosaurs were generally small compared with many later forms. Animals such as the Eoraptor walked on two legs and had light, agile bodies. Their modest size helped them move through a world still dominated by other reptile groups. Herrerasaurus from late Triassic Argentina was one of the earliest large predatory dinosaurs. It walked on powerful hind legs, grasped with long hands, and carried sharp, recurved teeth suited for holding flesh. During the Triassic, most land formed the single vast continent of Pangaea. Its interior was often hot and seasonally dry, and the first dinosaurs lived beside crocodile relatives, mammal ancestors, and many now extinct reptiles. A mass extinction at the end of the Triassic, about 201 million years ago, removed many competing animal groups. Dinosaurs survived and became far more diverse during the Jurassic period that followed. Dinosaurs are broadly divided into two major hip groups, Saurischians and Ornithischians. The names refer to pelvic structure, although the evolutionary history behind these groupings has been debated and refined as new fossils are discovered. Sauropods were the largest animals ever to walk on land. Their long necks, column-like legs, enormous bodies, and long tails created a remarkably successful design that persisted for more than 100 million years. Many sauropod bones contained air-filled spaces connected to a bird-like respiratory system. These spaces reduced skeletal weight without removing strength, helping very large animals support long necks and efficiently move air through their lungs. Diplodocus had an exceptionally long tail made from dozens of vertebrae. The final bones became thin and whip-like. Scientists continued to study whether such tails were mainly used for balance, display, defense, communication, or several purposes. Brachiosaurus differed from many sauropods because its front legs were longer than its hind legs. This gave the shoulders a high position and allowed the neck to rise above the back in a gently sloping silhouette. Sauropods did not chew their food the way mammals do. Their teeth mainly stripped leaves and clipped vegetation. Large amounts of plant material were swallowed and broken down slowly within an expansive digestive system. Some sauropods swallowed smooth stones, called gastroliths, although scientists debate how important these stones were for digestion. Similar stones can also enter a skeleton's surroundings naturally, so each discovery must be interpreted carefully. Fossil trackways show that sauropods often traveled with their feet placed close to the body's center line. Some track sites contain parallel trails, suggesting that groups moved across floodplains together. Juvenile sauropods had proportionally shorter necks and lighter bodies than adults. Their rapid growth may have helped them pass quickly through vulnerable stages, although even the largest species began life inside surprisingly small eggs. No known dinosaur laid an egg remotely close to the size expected from its adult body. Eggshell must remain thin enough for oxygen to pass through, creating practical limits even for giant sauropods. Stegosaurus lived during the late Jurassic, long before Tyrannosaurus. More time separated Stegosaurus from Tyrannosaurus than separates Tyrannosaurus from people living today, a reminder of the extraordinary depth of dinosaur time. The plates along a Stegosaurus back were not fused directly to the spine. They grew within the skin and contained grooves for blood vessels. Their exact role may have included display, species recognition, and possibly temperature regulation. The four spikes at the end of a Stegosaurus tail formed a defensive weapon often nicknamed a thagomizer. Injuries found on some predatory dinosaur bones are consistent with powerful blows from such tail spikes. Allosaurus was a major predator of late Jurassic North America and Portugal. Its skull was large but lightly constructed, and its arms carried 3 clawed fingers. It likely attacked with a combination of jaws, neck muscles, and grasping limbs. Predatory dinosaur teeth were replaced throughout life. When one tooth was damaged or shed, another grew beneath it. Fossil jaws sometimes preserve several generations of developing teeth packed inside the bone. Some theropod teeth had serrated cutting edges, rather like tiny steak knives. Microscopic study of those serrations can reveal how teeth resisted cracking and how different predators processed food. The largest dinosaur bones were not discovered all at once. Many giant species are known from incomplete skeletons because enormous carcasses were difficult to bury rapidly and were often scattered before fossilization. Fossilization is rare. Most dead organisms are eaten, decay, or weather away. A dinosaur usually had to be buried relatively quickly by sediment, then remain protected, while minerals gradually filled spaces or replaced original material. A fossil bone is not simply a stone shaped like bone. Many retain microscopic structures from the original tissue, including growth patterns, blood vessel channels, and the cellular architecture that once supported a living animal. Scientists can cut extremely thin sections of fossil bone and examine them under a microscope. Growth lines, tissue organization, and healed injuries provide clues about age, growth speed, metabolism, and life history. Some dinosaurs grew rapidly. Bone tissues rich in blood vessel channels show that young individuals could add skeletal material quickly, reaching large size in years or decades rather than growing slowly for centuries. Dinosaurs did not all have the same body temperature. Evidence suggests a range of metabolic strategies, with many species more active than modern reptiles, and some possessing physiologies approaching those of birds. Birds are living dinosaurs. They evolved from small feathered theropods, and their skeletons preserve many familiar dinosaur traits, including hollow bones, wishbones, three-toed limbs, and eggs laid in nests. Feathers appeared before powered flight. Fossils show simple filaments and elaborate plumage on non-flying dinosaurs. Feathers likely first served insulation, camouflage, display, brooding, or sensory roles, before some lineages used them in flight. Archaeopteryx lived about 150 million years ago. It had flight feathers and wings, but also teeth, clawed fingers, and a long, bony tail, creating a beautiful evolutionary mosaic of bird and dinosaur characteristics. Microraptor was a small feathered dinosaur with long flight feathers on both arms and legs. Its four-winged body probably glided or flew through Cretaceous forests, although researchers still investigate precisely how it moved. Some fossil feathers preserve microscopic pigment structures called melanosomes. By comparing their shapes with those in living birds, researchers can estimate whether a dinosaur carried black, reddish, iridescent, or patterned plumage. Sinosauropteryx had a banded tail, with alternating light and darker colors. This was among the first direct color patterns reconstructed for a non-avian dinosaur, turning a fossil outline into a more vivid living animal. Not all theropods were meat eaters. Therizinosaurs had enormous claws, but plant-eating adaptations, while ornithomimosaurs and oviraptorosaurs probably ate varied diets. Evolution repeatedly reshaped the theropod body for new ecological roles. Therizinosaurus carried some of the longest claws known in any land animal. The claws were too thin for heavy combat and may have helped pull branches closer, defend the animal, or communicate through display. Oviraptor received a misleading name, meaning egg thief, because its fossil was found near a nest. Later discoveries showed that similar dinosaurs were brooding their own eggs, arranged carefully in rings beneath the adult. Dinosaur nests reveal sophisticated behavior. Eggs were arranged in circles, mounds, or rows, depending on the species. Some nests were reused in colonies, while adults of several groups guarded or brooded their clutches. Maiasaura means good mother lizard. Fossil nesting grounds in Montana contain eggs, babies, juveniles, and adults. The evidence suggests hatchlings remained in nests for a time and may have received food or protection. Eggshell fragments contain microscopic pore patterns. These pores exchange gases with the surrounding air or sediment. Their distribution helps scientists infer whether eggs were exposed, covered with vegetation, or buried. Some fossil embryos remain curled inside their eggs. Their bones reveal growth stages and even pre-hatching postures, allowing scientists to compare dinosaur development with the embryos of modern birds and crocodilians. Hadrosaurs are often called duck-billed dinosaurs because their snouts ended in broad beaks. Behind the beak, tightly packed dental batteries held hundreds of teeth that created powerful grinding surfaces for tough vegetation. Hadrosaur teeth were continually replaced. Several teeth could occupy each position in the jaw, with fresh crowns moving into use as older surfaces wore away. This system was one of the most complex chewing mechanisms among reptiles. Edmontosaurus fossils preserve patches of skin, revealing small scales arranged in patterns. Rare specimens also preserve a fleshy crest along the head, showing that soft tissues could dramatically change a dinosaur's appearance. Parasaurolophus carried a long, hollow crest connected to its nasal passages. Computer models and physical reconstructions suggest that air moving through the crest could produce deep, resonant sounds for communication. Lambeosaurine hadrosaurs had crests in many shapes. These structures changed as the animals matured and differed between species, making them useful for visual recognition as well as sound production. Fossil trackways sometimes record ordinary moments with surprising clarity. A trail can preserve walking speed, foot shape, direction, and whether an animal moved alone or beside others across wet sediment. Some dinosaur footprints contain impressions of skin scales. Others show where toes slipped or mud squeezed upward. Such subtle details help researchers reconstruct how a living foot contacted the ground. Dinosaurs lived on every continent, including Antarctica. Fossils found there record animals that endured long polar winters. Although the Mesozoic climate was generally warmer and Antarctic forests once grew at high latitudes. Polar dinosaurs experienced months of unusual light and darkness. Bone growth and fossil plants suggest they adapted to strong seasons, and some may have remained through winter rather than migrating vast distances. During much of the Mesozoic, sea levels were higher than today. Shallow inland seas divided continents and created coastlines where dinosaur remains could be washed into marine sediments beside shells and sea reptiles. Spinosaurus lived in Cretaceous North Africa, near enormous river systems. Its long jaws and conical teeth resemble fish-catching adaptations, and dense bones plus a tall back sail indicate a lifestyle unlike that of most other theropods. Scientists continue to debate exactly how Spinosaurus moved and hunted. New bones have changed reconstruction several times, demonstrating how paleontology improves through testing, disagreement, and additional evidence. Carnotaurus had a short, deep skull and two thick horns above its eyes. Its arms were extremely reduced, even compared with those of Tyrannosaurus, while its hind limbs suggest an animal adapted for rapid movement. Tyrannosaurus rex lived only near the very end of the dinosaur age, between about 68 and 66 million years ago. It inhabited western North America alongside Triceratops, Edmontosaurus, and Ankylosaurus. Tyrannosaurus had one of the strongest bites known among land animals. Thick, deeply rooted teeth could crush bone, and fossil droppings containing pulverized bone show that hard skeletal material sometimes passed through its digestive system. The arms of Tyrannosaurus were small but strongly muscled. Each hand had two functional fingers. Their exact use remains uncertain, but they were not useless simply because they were short. Growth studies indicate Tyrannosaurus experienced a rapid adolescent growth spurt. It transformed from a lightly built juvenile into a massive adult, changing proportions and perhaps hunting strategies as it matured. Juvenile tyrannosaurs had longer legs and narrower skulls than adults. Their different body forms suggest that young and mature individuals may have pursued different prey, reducing competition within the same species. Coprolites are fossilized droppings. A large coprolite attributed to a tyrannosaur contains fragments of young plant-eating dinosaur bone, offering direct evidence of a meal consumed millions of years ago. Bite marks on dinosaur bones can reveal feeding behavior. Some healed marks show that the bitten animal survived, while repeated marks on carcass bones can identify where a predator or scavenger sought muscle or marrow. Triceratops had a solid bony frill, a short nose horn, and 2 long brow horns. The horns changed shape as the animal grew, suggesting that display and recognition were important alongside any defensive role. Triceratops and Tyrannosaurus truly lived at the same time and place. Fossil bones with healed or unhealed bite marks provide rare evidence that these famous dinosaurs sometimes interacted as predator, prey, or scavenger and carcass. Ceratopsian dinosaurs began as relatively small, lightly built animals in Asia. Over time, some lineages developed enormous skulls, elaborate frills, and horns before spreading widely across Cretaceous North America. Psittacosaurus was an early ceratopsian with a parrot-like beak. Exceptional fossils preserve a fan of long, bristle-like structures on the tail, demonstrating that dinosaur skin coverings were more varied than scales alone. Ankylosaurs carried armor made from bony plates, called osteoderms, that formed within the skin. These plates varied from small pebbles to broad shields, spikes, and in some species, a heavy tail club. The tail club of Ankylosaurus was built from enlarged vertebrae stiffened together and capped by large bony knobs. Strong muscles could swing the structure, possibly delivering dangerous blows to an approaching predator. Pachycephalosaurs had thickened skull roofs, sometimes surrounded by knobs and spikes. Scientists debate whether they struck rivals head-on, used flank-directed blows, displayed their domes, or combined several behaviors. Small injuries and disease are preserved in fossil bones. Dinosaurs suffered fractures, infections, arthritis, tumors, and tooth damage. Healed wounds show that many survived trauma for months or years. One famous Allosaurus specimen has numerous damaged bones, including healed injuries. Its survival suggests that even a large predator could continue living after serious accidents in a physically demanding world. Fossilized stomach contents are extremely rare, but valuable. Leaves, fish scales, small bones or stones, preserved within a body outline, can provide direct evidence of an individual animal's final meals. Dinosaur soft tissue almost always decayed, yet rare fossils preserve skin, feathers, claw sheaths, stomach contents, and body outlines. Fine-grained sediment, low oxygen, and rapid mineral growth can capture these delicate details. Amber sometimes preserves feathers that detached from dinosaurs or early birds. Under magnification, their branching structure remains visible, providing a three-dimensional record unavailable from flattened rock fossils. Flowering plants appeared and diversified during the Cretaceous. Dinosaurs therefore witnessed a major botanical transformation as landscapes gained new leaves, flowers, fruits, and ecological relationships with insects. Grass existed before the end of the Cretaceous, although it did not yet form the vast grasslands familiar today. Tiny silica bodies found in fossil dung show that some plant-eating dinosaurs consumed early grasses. Many dinosaurs probably had excellent color vision. Living birds and reptiles possess sophisticated visual systems, and bright feathers, crests, horns, and skin structures would have been most useful in a visually rich world. The dinosaur inner ear can be reconstructed from skull scans. The shape of balance organs and the length of the cochlear region provide clues about head movement, posture, hearing sensitivity, and activity patterns. Some small predatory dinosaurs had facial discs and asymmetrical ear openings resembling those of owls. These adaptations may have helped them locate quiet prey in darkness with remarkable precision. CT scanning allows scientists to look inside fossil skulls without damaging them. Digital models reveal brain cavities, sinuses, nerve passages, replacement teeth, and delicate bones hidden within solid rock. A dinosaur brain did not fill every space inside the skull. Researchers create endocasts of the brain case, but these models also include membranes, blood vessels, and other tissues, so interpretations remain cautious. The idea that every dinosaur was slow and unintelligent is outdated. Their abilities varied widely, just as those of living animals do. Complex senses, parental care, social signals, and flexible movement are evident in many groups. Some dinosaurs may have rested in bird-like sleeping postures. Fossils of small feathered dinosaurs preserve bodies curled with the head tucked beneath an arm, conserving warmth in a pose still used by birds tonight. Sleeping dinosaur fossils are exceptionally rare because a resting body normally decays or is disturbed. Rapid burial by volcanic ash or sediment could preserve the animal almost exactly where it settled down. Dinosaur names often describe anatomy, location, or people. Triceratops means three-horned face, while Tyrannosaurus means tyrant lizard. A formal scientific name must follow international rules and be supported by a published description. New dinosaur species are still named every year. Many come from recently explored rocks, while others emerge when scientists re-examine fossils stored for decades in museum collections. A complete dinosaur skeleton is extraordinarily uncommon. Museum mounts often combine casts from several individuals, mirror missing bones from the opposite side, or use reconstructed pieces clearly documented by curators. Fossil preparation can take longer than excavation. Technicians use fine needles, tiny drills, microscopes, adhesives, and patience to separate fragile bone from rock, without erasing important evidence. The age of dinosaur-bearing rock is measured with several methods. Volcanic ash layers can contain radioactive minerals that act as clocks, while magnetic reversals and distinctive fossils help correlate layers across regions. Fossils are interpreted within their geological context. The grain size, sediment structures surrounding plants, pollen, shells, and chemistry of a rock layer help reconstruct the environment in which an animal lived and died. The Chicxulub impact occurred about 66 million years ago near what is now Mexico's Yucatan Peninsula. The buried crater is roughly 180 kilometers wide, evidence of an asteroid with global consequences. The impact blasted dust, sulfur compounds, and debris into the atmosphere. Sunlight diminished, temperatures changed, and food webs collapsed. The geological boundary contains iridium and shocked minerals associated with the event. Large volcanic eruptions were also occurring in India around the end of the Cretaceous, forming the Deccan Traps. Scientists study how this long volcanism affected climate before and after the asteroid impact. About 3/4 of species disappeared in the end Cretaceous mass extinction. All non-avian dinosaurs died out, along with ammonites, pterosaurs, and many marine reptiles, while some birds, mammals, reptiles, and amphibians survived. The birds that survived were generally small, and many may have lived near the ground or water. Their descendants later diversified into the more than 10,000 bird species that inhabit Earth today. Every sparrow, owl, penguin, and hummingbird is part of the dinosaur story. Features once considered uniquely avian developed step by step among their Mesozoic ancestors long before the final extinction. Paleontology is a science of revision. A new skeleton, trackway, chemical analysis, or scanning method can overturn a familiar reconstruction. Changing an idea in response to stronger evidence is a sign that the science is working. Dinosaurs were not a single experiment that failed. They flourished for more than 160 million years, occupied every continent, evolved into astonishing forms, survived through birds, and continue to reveal new chapters from the rocks. Now our path through dinosaur time has reached the quiet present. The forests have changed, the continents have moved, and the great bodies have returned to stone, but birds still carry the lineage into every dawn. Let those immense stretches of time make the room around you feel calm and small. You do not need to follow another footprint tonight. Allow the facts to fade, the ancient landscapes to soften, and your thoughts to settle. Rest well, and good night.